particular exposure. Now, some people might denigrate this as an anecdote, and technically it is an anecdote, but it's also a critically important part of the epidemiologic scientific process. When the FDA figures out that a drug that has been put on the market causes side effects that weren't anticipated, perhaps because they're rare, perhaps because they only happen with interactions that nobody had actually studied in the pre-approval process, they almost always figure this out because of their adverse event report collecting, and typically act based on that information from the adverse event reports. When we hear about something like the recent disease outbreak with cantaloupes causing foodborne illness, we learn about that because of individual adverse event reports that someone pieces together and figures out what they have in common, in that case, obviously, cantaloupes. And indeed, it's how we discover most of the acute hazards, such as a model of car that has faulty brakes, or a piece of children's furniture that has some dangerous characteristic. Once it's out there in the world, that's the type of research where most of our epidemiologic knowledge comes from. And it's no different with the case of wind turbines. This was a technology that, for good or for ill, people thought wouldn't cause any health problems before they started putting it out into the world. Whether they should have or not is a different question, but it's a question that's long in the past and doesn't matter. But because we have the exposure in place, we were able to start collecting this information. And collect it we did. In the case of these industrial wind turbines, there have been thousands of these adverse event reports published. Most all are self-published in some ad hoc way. Someone creates a blog, puts them on a website, puts them on a collected blog, starts circulating them by email, tells one reporter about them, and they end up in the newspaper somewhere. But several researchers, including my research group, have tried to systematically gather these together. For example, the Wind Voice project in Ontario is an attempt to replicate FDA-style adverse event reporting. Because adverse event reports are so critical to understanding post-market effects of drugs, the FDA, the US FDA, has a system in place to collect these adverse event reports, knowing that that's where most of the information is going to come up about these things. Wind Voice was an attempt to replicate that. My own approach has been to try to gather a lot of them together to use some text mining methods. I haven't finished that project yet, but there's enough information that we can actually learn quite a lot from these reports. This isn't just one person out there reporting something and expecting us to believe that there's a major health problem because of one story. Now, for reasons I'll detail in a few minutes, these reports are even more compelling than, say, the reports about drug adverse events and so forth. But before I get too technical and sciencey about that, I want to emphasize the humanity of some of these reports. If anybody who's involved in this process or who's just interested in it hasn't had a chance to pick a dozen of these at random and read through them, you really ought to. 3 of them appear in an appendix to that article I recently published, and hundreds more are quite easy to find. These are heartbreaking stories of people who've had their lives disrupted because of these health problems, these health problems that really mess up your life. If you break your leg, that's a bad thing. Certainly it's unpleasant, it's going to affect your life, but it doesn't affect your mood, it doesn't affect you it doesn't keep you from working, it doesn't make you too fatigued to concentrate and to read, it doesn't make you snap at people because you have a stress-related anger disorder caused by it. These are extremely disruptive results for someone or their family to suffer. We can sit here and talk coldly about health effects, sleep disorders, technical terms, and indeed I'm mostly going to do just that because that's what I do. But only by reading these stories can you really appreciate the human side of things and what it means for real people who have suffered these problems, who have had to abandon their homes in many cases, and who have otherwise found that what had been their sanctuary, their home, their family's land is now a hostile environment for them to set foot in. Before coming back to the point about how compelling these adverse event reports are, I want to mention that there have been several systematic analyses. Now, a systematic analysis is what you might typically think of as a study, where a defined group of people is studied, interviewed, otherwise looked at, the type of information that tells us about what causes cancer risk, or what causes heart attack risk, and so on. In fact, these are about the only kind of studies that can tell us about cancer risk for reasons that I will mention. They are not nearly the only type of useful information about an exposure like this. But the key point is these have happened. Some of the early reports, even as recently as a year ago, some industry reports claim, there's absolutely no evidence of this type out there. Well, there is, and there's more every month. There was a new paper that just came out this month about a study in New Zealand by Shepard et al. A group led by Michael Nissenbaum in Maine have done several studies that have come out in various forms. There were some studies in Europe by a group led by Peterson, although that wasn't focused on exactly the health effects, unfortunately, so we don't know as much about it as we want to know. The key here is these are not our primary source of knowledge. These are some small studies of very limited populations, because these studies are difficult to do. They're expensive and nobody's funding them, so it's been quite difficult to get them done. But the real key is they agree with the overwhelming evidence that we have, the evidence from the adverse event reports. None of these studies have come back and said, no, when we look at it this way, when we study things more systematically, there doesn't seem to be any problem after all. So those thousands of people who self-reported serious problems must have just been imagining it. Different data collected in different ways, analyzed in different ways, agrees with this other information we have. And that's very useful from a scientific perspective, even though we would like to have 50 of these studies out there, and we only have more like 5. So lacking those, what can we do? We can deal with these adverse event reports, which in this case are extremely compelling in ways that wouldn't work for studying, say, whether chemical pollution is causing cancer. One thing that's very useful about them, very reassuring that we have a problem here, is that there's a consistent pattern of reported diseases. Now, yes, in many of these reports, you'll find sort of a stray claim, where somebody reports that they're having sleep problems and they're getting in more fights and they can't do their work. Oh, and, grandmama came down with diabetes also. Well, we go through them and we say, okay, the diabetes doesn't show up typically. It's not plausibly related like these other things are. Somebody mentioned that once, but the consistency is quite amazing. This is not the type of thing that you see when, say, people living near a toxic waste site or what they fear is a toxic waste site start complaining about problems. And this person had cancer, and this person had osteoporosis, and this person had diabetes, and we blame it all on the toxic waste site. We see the same problems over and over again in a very consistent manner, reported in a very consistent way. Furthermore, and most importantly, we have people conducting what in the jargon we call case crossover studies. Now, a case crossover study is in some ways the simplest possible form of health science. It was discovered by our simian ancestors before they discovered language. It consists of doing something like, I ate this food and it made my stomach hurt. Maybe I shouldn't eat that. So you don't eat it and your stomach stops hurting. Now, if you're really scientifically minded, or you don't have anything else to eat, you might eat it again. And you find, my stomach hurts again. Case crossover refers to the fact that the exposure is crossing over. You went from unexposed, you hadn't been eating that food, your stomach didn't hurt, to exposed, you ate the food, your stomach hurt, to unexposed, you stopped eating it, and you got better again. And you can do that as many times as you want until you're convinced. Again, this is one of the most common methods and ancient methods of scientific research, though it didn't actually get that name until 1991 when Malcolm McClure gave it the name case crossover study, but is widely misunderstood, perhaps intentionally and in some cases by those who would like to claim that there are no health effects. Most of the adverse event reports that I have seen, probably a majority of those out there, can include some crossover evidence. There's the observation, almost always, that these problems started shortly after the nearby turbines went online. That we didn't have these problems before, then we had them. Many of these reports, almost all of them, have time away. People take vacations or in some cases decide that they have to move. They're away for a week, they notice that their problems clear up. They come back, they start up again within a day or a week, depending on individual sensitivity. Finally, somebody moves away. That's actually the story in disturbingly many of these cases that are reported. They have to move away from their homes, and their problems get better. This is the type of incredibly compelling experimental evidence that would convince you that the onions that you eat to make your stomach upset are really not something you ought to be eating. This is in many ways better than the typical study of cancer or a typical study of heart disease, where we have to gather together a whole lot of people and wait to see if a few of them get cancer. Ask them hundreds of questions to figure out what caused this. We only get one observation per person when we're doing a study like that. They either get cancer or they didn't. So you have to have thousands of people in your study. One individual, one family can do an awfully good experiment on himself in a situation like this and figure out that there is a problem. And if you look at those studies, people intuitively understand that kind of scientific reasoning and perform that experiment on themselves. The key to this, unlike a case like cancer, you need a disease with a clear onset. Well, we have that. Sleep disorders and many of these things are a little bit difficult to detect when they started, but they're not like something like cancer or heart disease that has been silently growing for years before it's actually diagnosed. You need a disease that can go away when the exposure ends, and these fortunately are diseases that somebody can cure themselves of by moving to somewhere else. You need an exposure with a clear starting point. Turbine started spinning, you were in your house, and ending points that you can get away from. I went on vacation, I moved away. And it's also useful that it's very unlikely that there are coincidences. Now, sometimes people say, well, lots of people have sleep disorders, lots of people have headaches. At any given time, maybe 20% of the population has a problem with that. But what they don't have is the sleep disorder starting in a particular week and going away in another particular week when the exposure ended and starting again when the exposure started up again. That would be an incredibly, incredibly statistically rare coincidence to observe even once this exact pattern, let alone hundreds and hundreds of times. So we actually, as difficult as it is to pull the evidence together about this, because it's not these neat packaged studies that we're used to seeing about other topics, we actually have more compelling evidence than we have about any number of other topics that typically show up on the health page of the newspaper saying, guess what, everybody, eating broccoli is bad for you this week. It was good for you the previous week. Well, that's because those types of studies are a little futzy, and they, depending exactly how you analyze them, they might come out one way, might come out another. Nothing nearly so compelling as the evidence that we have here. Now, one thing that this type of data doesn't do for us, as I've already pointed out, is tell us exactly how many people are likely to suffer when faced with a particular exposure. If you wanted to answer that question really precisely, and you wanted to know the answer to, okay, if there are 100 100 families 1 mile away from the nearest wind turbine, how many cases of serious disease might you expect to see, and how many other complaints of health effects might you expect to see? Unfortunately, we can't get as good an estimate of that as we would like to, which in my mind says that we need to do more study before we need to do more exposure. But that's my personal opinion as a public health professional. But